What if AI data centers could heat your home, feed your compost bin, and build your fence? AI is famous for two big appetites: electricity and water. Massive data centers packed with servers run hot, and keeping them cool takes a lot of both. But there's a less talked about byproduct of all that cooling: heat. And heat, it turns out, doesn't have to be wasted. Here's an idea for turning a data center's leftover heat into a whole chain of useful things: extra electricity, biogas, fertilizer, and even waterproof building materials, before any of it ever touches the ocean. Step 1. Keep the servers cool. Servers generate heat constantly, so data centers run water through them in a loop to carry that heat away. To avoid damaging expensive equipment, this water stays in a closed loop. It circulates and cools the servers, then goes off to dump its heat somewhere else, and comes back to do it again. Simple enough. Step 2. Squeeze out a little free electricity. Before that warm water is used for anything else, it can pass through a small generator that runs on a special low boiling point fluid, similar to what's inside your refrigerator or air conditioner. Because this fluid boils at a much lower temperature than water, it can turn even lukewarm water into a bit of spinning turbine electricity. It's not a lot, maybe 5–15% of the heat gets converted, but it's essentially free electricity, skimmed off water that would otherwise just be discarded. Step 3. Turn up the heat without burning anything. The water leaving the servers is only warm, not hot enough for most serious uses. That's where a heat pump comes in. You already own one. It's the same technology inside your fridge or air conditioner, just running in reverse. A heat pump can take a large amount of lukewarm water and concentrate its heat into a smaller amount of much hotter water, using surprisingly little electricity to do it. Think of it like squeezing a big, weak signal into a small, strong one. This step turns kind of warm water into genuinely useful hot water, hot enough to power the next two ideas. Step 4a. Feed a neighborhood compost machine. That hot water can keep a biodigester running at the perfect temperature. A biodigester is essentially a giant stomach, a sealed tank where microbes break down organic waste, food scraps, sewage, garden waste, the way your gut breaks down food, except these microbes produce methane gas as they work. That gas can be burned for electricity or heating. What's left over makes excellent fertilizer. And because the whole process depends on keeping the tank at a steady, warm temperature, a data center's endless supply of leftover heat is a perfect match, especially somewhere cold, where a biodigester might otherwise struggle in winter. Step 4b. Turn plastic waste into building material. The same hot water can also help solve a very different problem: what to do with plastic waste that's too mixed or contaminated to recycle normally. Instead of trying to melt it back into pure plastic, waste plastic can be washed, dried, and used as filler inside molded panels, things like fake log cabin siding or fake bamboo fencing, both of which already exist as products made from plastic. Because these panels never rot, warp, or need repainting, they double as a waterproof outer skin for buildings, protecting whatever's underneath from rain and moisture, on top of just looking nice. The washing and drying step for the plastic needs warm water too, right in the range the data center's heat pump can supply, so it slots neatly into the same system. Step 5. Only send the ocean what's left. By this point, the water has already given up its most useful heat. A little electricity here, the digester's needs there, the plastic washing step 2. Whatever mild warmth is left finally gets released into the sea through a heat exchanger, similar to a system already used at a real data center in Finland. Because the water and seawater never actually touch, there's no contamination risk. It's just a handoff of heat, one last time, before the loop starts over. Why the order matters. This only works because each step happens in the right order: biggest, most valuable use of the heat first, smallest leftovers last. Skimming electricity happens early, while the water is still at its best temperature. The heavy lifting, heating the water up further, happens next, aimed at things that actually need real heat, like the digester. And the ocean, which doesn't care what temperature it receives, gets whatever's left at the very end. Get the order wrong, say, sending everything to the ocean first, and you throw away energy you could have used. Get it right, and almost nothing goes to waste. The big picture. None of these pieces are science fiction. Data centers cooled by seawater already exist. Waste heat already warms homes in parts of Scandinavia. Biodigesters already turn food waste into gas and fertilizer. Recycled plastic siding is already sold in stores. What's new here is chaining all of them together, so a single AI data center's leftover heat doesn't just disappear into the ocean, but instead helps power a home, feed a compost system, and build a fence, all before it's finally let go. It's a reminder that waste heat is really just heat nobody's found a use for yet.